Hello everyone. Today we are going to start solving rational equations, but before we do that, I just want to go over, have you guys try these two warm-up review problems. So pause the video, give these a try. Notice in number 1 we're simplifying, 2 we're solving. So pause the video, give these a try, and then resume playing. All right, if you need more time, pause again. So in our first example here, we are dividing radicals. So remember the division rule with radicals, that if we have radical A over radical B, we could put this back together as one big radical, or we could simply just divide what's underneath, but keep it underneath the radical. So for instance, 120 can divide by 10 since they're both underneath the radical, so we're going to get the square root of 12. And then where do I have more x's? In the numerator, how many more? 4. And now we can simplify this. So for the 12, I'm going to factor this into 4 times 3, and then x to the 4th I'm going to leave alone. So I'm going to take the square root of 4, and then the square root of x to the 4th. So that will become a 2x squared, and then I still have a radical 3 left. Now in number 2, we're solving, so in this case, I do have just a number underneath the radical, not a variable. So what I want to do is add 3x radical 2 to both sides. And now I do this because I'm going to factor out an x, and this is going to leave me with a 1 plus 3 radical 2. Now I want to solve for x, so that means I need to divide by this binomial, so I'm just going to write it this way. X is going to equal 5 over the quantity 1 plus 3 radical 2. Now I want to rationalize the denominator, so I need to multiply by the conjugate here, which is 1 minus 3 radical 2. So I'm going to distribute the 5. So up top, we're going to get 5 minus 15 radical 2. In the denominator, I'm going to have a 1. My outside and my inside terms are going to cancel because these are conjugates. Next, I'm going to have positive 3 times negative 3 is a minus 9. And then radical 2 times 2 is a 2. So we end up with 5 minus 15 radical 2 over 1 minus 18, so we get a negative 17, and I can reverse this. We could say it's fine to leave it like this, or we could say negative 5 plus 15 radical 2 over 17. All right, so now since we're transitioning into rational equations, and that's our goal for today, we're going to be able to solve. Remember, we solve equations, we simplify expressions. So I want to go over the differences, because now that they're going to get all mixed together, it is going to be a little confusing at times. So we have to make sure we fully understand the differences here. So for rational expressions, these can only be simplified, not solved. This is where we go through the steps where we factor, we state restrictions, we cross out. We do this for simplifying a single fraction, multiplying and dividing. When we add or subtract. And this is the most important one because this is where the rational equations are going to get mixed in. And the rules, we have to be very careful here. When we add or subtract, we use the LCD to make one big fraction. But we keep the denominators. That's the big part there. Over here for rational equations, we want to solve. But we use our LCDs, we end up eventually clearing the denominators. So we multiply, I'm going to abbreviate the equation this way. We multiply the equation by the LCD to clear. We want to get rid of the denominators. So clear denominators with equations, keep denominators when we're adding and subtracting fractions. All right, so I'm going to list some steps here. To solve a rational equation, we're going to determine the LCD. But we also need to state restrictions. It's very important here because if we get an answer that's a restriction, we can't keep it. And I'm going to try to keep this as simple as possible. So we determine the LCD, we state restrictions. And then we're going to, and we could do this at the very beginning or we could do this later on, and I'm actually going to show you this later on, but we want to multiply the equation by the LCD to clear denominators. Then we continue solving and we check solutions. I'm going to abbreviate solutions this way. Check our solutions. Now, once we do clear denominators, we're going to be left with one of two types of equations. So there are two types of equations that can result after clearing denominators. The first could be linear, and the second would be a quadratic. A linear means we just see a single variable. It's not raised to any power larger than 1. So for an example here, linear could be maybe we have a 5x plus 2 equals a 3x minus 7. We just simply continue to solve for x. But a quadratic could be x squared plus 7x plus 12. And in this case, quadratics, we want to get everything on one side, all the terms on one side set equal to 0, and we usually solve by factoring. But it's very important that we want to check our solutions, because like I mentioned before, if we get a solution that matches a restriction, it's called an extraneous solution. It just means we have an extra solution that does not satisfy our equation. All right, so at least with our first example, I'm going to do this two ways, and then you guys can choose which way you prefer. Let's go ahead and take a look at example 1. So I'm sort of just going to divide this page here, and I'll solve it a second way here in a moment. All right, so for number 1, we want to first determine our LCD. What's nice is I have nothing but numbers. So 3, 4, and 2, they can all go into 12. So my LCD is 12. I don't have any variables in my denominator, so there are no restrictions. So what I want to do is go through and multiply each fraction by 12 or 12 over 1. And any binomials I want to put in parentheses. All right, so all I did was I rewrote the problem, the entire equation with the 12 over 1 in front. And now this is what we can do. Since I chose 12, 3 goes into 12, so the 3 is going to cross out, become a 1, 12 will become a 4. So now what do I have left? 4 times the quantity 2x plus 1. Fraction went away. Minus 4 goes into 12 3 times, so now I have a minus 3 times the quantity x minus 5. And then this is just 12 divided by 2, or half of 12, so that will give me 6. Now I have an equation with no fractions. I just continue to distribute. Now I would classify this as linear. I don't have any x squares. I'm not going to get any x squares. So I'm going to have an 8x plus 4 minus 3x plus 15 equals 6. Combine my like terms. 8x minus 3x will give me a 5x. 4 plus 15 will give me a 19. Subtract 19 from both sides, so 5x is going to equal a negative 13. And x equals negative 13/5. Now I would advise checking this on a calculator, but because there's no restrictions, we're not going to have any extraneous solutions here. But this would be our answer. All right, so here's the other way. If we didn't use the 12 first, this is what we could do. Again, we know our LCD is 12. So we can make every fraction have this LCD of 12. So I know 3 got multiplied by 4, so I can multiply the 2x plus 1 by 4. The 4 got multiplied by 3, so I would multiply the x minus 5 times 3. And then the 2 had to get multiplied by 6. So what I could do now, and it's really that I'm multiplying everything by 12, but if all my denominators are the same, I could just cross those out, and that means all my numerators have to be the same. So I could just cross all these out now, because technically I'm multiplying everything by 12. And then I'm left with 4 times the quantity 2x plus 1 minus 3 times the quantity x minus 5 equals 6. And that's this step right here. So 2 different ways. What I did first was, instead of writing the common denominators here, I just simply multiplied by the LCD. Or over here, I could get the common denominators and then cross them out. All right, let's take a look at number 2. I'll do this one the same way. I'll show you both ways. All right, so first let's determine the LCD. Here we have binomials. There's nothing to factor, so the LCD is both of these, x plus 2 and an x minus 2. I do have restrictions. This first x cannot equal a negative 2. The second x cannot equal a positive 2, and then this one over here as well. So what I'm first going to do is multiply everything throughout by the LCD of x plus 2, x minus 2. I know this is a lot to write out, but here's my first fraction being multiplied by that LCD. Minus, here's my LCD again, times the x plus 2 over x minus 2. And then times the x plus 3 over x minus 2. So as I go through, I'm going to cross out what is going to divide out here. So the first, I'm going to cross out the x plus 2. So what do I have left? I have an x times an x minus 2. Over here, my middle part, still have a minus. The x minus 2's are going to cross out. And because I'm subtracting here, inside I have to multiply x plus 2 times x plus 2, but then I would have to subtract all those terms. And then over here, again, the x minus 2's cross out, and I have x plus 2 times the quantity x plus 3. Now I'm just going to go through, distribute, combine like terms. So first I'm going to have an x squared minus 2x minus, still going to keep this in brackets. When I multiply these two binomials together, I'm going to get an x squared plus 4x plus 4. Then over here, I'm going to get an x squared plus 5x plus 6. I'll go through and carefully subtract each term. So as I distribute this negative sign, I get a minus x squared minus 4x minus 4 equals x squared plus 5x plus 6. So notice we have some x squares, so this is a quadratic. Over here, these x squares cancel out, but I still have this x squared over here. So what I want to do, I'll go ahead and combine negative 2x minus 4x is negative 6x minus 4 equals x squared plus 5x plus 6. Now at this point, I want to bring these two terms over to set equal to 0. So when I do that, I'm still going to have an x squared. When I add 6x, that's going to add to the 5x, so that's 11x, and then I'm going to add 4 to the 6, so that's 10, and this side is 0. Now I need to solve by factoring. So I'm going to make two sets of parentheses. There's no GCF. We're going to have an x. Everything's positive, so it looks like x plus 10 and x plus 1 work. Now at this point, I set each factor equal to 0. And then we simply solve. So x is going to equal a negative 10 or a negative 1. Now I checked these against my restrictions, which were negative 2 and 2, so we're good. And again, if you wanted to check on your calculator, you would first check negative 10. You can substitute this back in. Negative 10 everywhere you see an x, and you can just try that on your calculator. And then go back in and evaluate that when x is equal to negative 1. So you could leave it like this, or you could write it in set notation that we have a negative 10 and a negative 1 as solutions. Okay, so let me show you the other way. Rather than multiplying by the LCD first, what we could do is get the 3 fractions over the LCD. Adjust our numerators. So this first x would have to get multiplied by an x minus 2. The second numerator would have to get multiplied by an x plus 2. But I'm still going to keep my brackets around that because it's after a minus sign. And then the x plus 3 would have to get multiplied by an x minus 2. And then what we would do at this point is just cross out our denominators because they're all the same. That means the numerators have to be equal. And then I'm left with this same step right here. X times the quantity x minus 2 minus the quantity of the product of these two binomials. And then equals quantity of x plus 3. That should have been an x plus 2 here. And then we can continue from there. So at this point, those two parts are the same. All right, so let's try number 3. Now, number 3, I'm actually going to start with the other way first. I think it might be a little bit easier. All right, first let's determine our LCD. And in order to do that, I need to factor this first denominator. So I'm going to factor out an x. There's a GCF of x, and then I have an x plus 3. So that is my LCD, because notice there's an x plus 3 here and an x here. So my LCD is x times the quantity x plus 3. My restrictions are x cannot equal, this first x is a monomial, that can't equal a 0. This x right here can't equal a negative 3. This x right here can't equal a negative 3, and this x right here can't equal a 0. So those are my two restrictions. So now let's just get everything over the LCD, which is x times the quantity x plus 3. All right, well, nothing changed from this first denominator, so I'm still going to have a 3 up here. The second denominator got multiplied by an x, so I need to multiply the numerator, x plus 2, by the x. And then the third fraction here, that denominator got multiplied by an x plus 3, so I would have x plus 3 here. So now at this point, because it's an equation, I can multiply everything throughout by the LCD, which means I can just cross these out. So now I'm left with 3 plus x times the quantity x plus 2 equals x plus 3. Distribute this x, so we'll get an x squared. So now we're at a quadratic. So I want to bring everything to one side. I want to write this x squared first. If I subtract x, that's going to apply to this 2x. So 2x minus x is x. And then 3 minus 3 is 0. So I'm left with x squared plus x equals 0. Now I'm going to factor, but in this case, there's a GCF of x, and then I have an x plus 1 left over. So I'm going to set this x equal to 0, so that's one solution, and then x plus 1 equals 0, so x is going to equal negative 1. But I go back and I check my restrictions. X cannot equal 0 or negative 3, so because this did equal 0, I would have a problem, so I can't keep this. Therefore, x equals negative 1 is my only solution. X equals 0 is an extraneous solution. Because as soon as I check this, right over here I would get a 1 over 0, and that's undefined. Same thing here, I get a 3 over 0, that's undefined. All right, so remember, we only cross out denominators once we get everything over that common denominator because it's an equation that we're solving. If I just gave you this left part of this, we would keep our denominators and make one big fraction. All right, so I just want you guys trying problems 1 through 4 only off of this new rational equations worksheet.